All right, let's get right into it. You've definitely been here before. You build a cool new feature, you go to load it up, and you get nothing. Just a spinner. Well, today we're going to pull back the curtain on a super powerful but often overlooked JavaScript technique that solves this exact problem. And we'll do it by telling a little story about two developers and one ridiculously large log file.
So this is where our story begins, that moment of pure frustration. I want you to meet Timothy. He's a junior dev, and he just built this really neat diagnostic dashboard. But when he tries to load a big server log, he gets this. 5 seconds of a totally blank screen before, bam, this massive wall of text just slams into view. His first thought? Must be a huge file on a slow network, right? But he's about to find out the real story is way more interesting than that.
And yeah, when we say a big file, we are not kidding. Timothy is trying to fetch and display a 15 megabyte text file. In the web world, that's gigantic. So it's no surprise that things are slow, but the reason they're slow, well, that's not what he thinks at all.
And this is the question that changes everything. It comes from his senior colleague, Margaret, and it's so simple, but it cuts right to the heart of the problem. See, she doesn't ask, why is the download taking so long? She asks, why is the screen blank? That tiny shift in focus, it's everything. This right here is the core misunderstanding. Timothy's doing what we all do. He was blaming the network. Big file means slow download. Makes sense, right? But Margaret points to something else entirely. The real bottleneck isn't the network pipe itself. No, it's that the browser is being forced to swallow all 15 megabytes in one single, massive, and really inefficient gulp.
And what's causing all this trouble? You're looking at it. It's this one single, totally innocent-looking line of code, await response.txt. I mean, its job is simple. Take a response, give me the text. You've probably written this line 100 times, but what you might not know is that with large files, it has a secret, performance-killing dark side.
And boom, there it is, the aha moment. This quote just explains it perfectly. When Timothy uses .textHue, he's basically telling the browser, hey, stop everything, just sit there and collect every single byte of this file in memory. And don't you dare do anything until you have the absolute last byte. It's this all-or-nothing approach, and it's choking the browser.
You know, this whole process actually has a name. It's called memory buffering. Think of it like this. You're trying to fill a bathtub with a fire hose, but you're not allowed to even get your hands wet until the entire tub is full to the very brim. It's just wildly inefficient. It makes your memory usage spike like crazy, and it's the direct cause of that dreaded blank screen.
So Timothy's next question is probably what you're thinking right now. Okay, wait a second. If the data is arriving in little pieces, in packets, over the network, can my JavaScript code really grab those packets one by one as they come in? I mean, that feels like it should be way too low level for a language like JavaScript, right? Well, the answer is a huge, resounding yes.
And this is how it's done. Welcome to the Streams API. This thing is a standard, built-in browser API made for exactly this situation. It lets you tap directly into the flow of data coming over the network, piece by piece, chunk by chunk, instead of waiting for the whole thing. It basically turns that fire hose we were talking about into a gentle, totally manageable stream.
So the streaming way replaces that one big clunky step with a simple, beautiful, continuous loop. First, instead of asking for .text, you ask for the .body, which gives you a readable stream. Then, as each little chunk of data flies in from the network, you read it, turn it into text, and immediately slap it onto the screen. You just keep doing that. Read, decode, render, repeat, until the stream says, I'm done. No more waiting.
And the change for the user? It's like night and day. That loading spinner is barely even there. The first few lines of the log file show up almost instantly. And then the rest of the content just flows onto the screen, smooth and progressive, just like a waterfall. The best part? The user can start reading and scrolling long before the full download is even finished. I mean, just look at these numbers. They really tell the whole story. The time it takes for the user to see anything on the screen drops from 5 long seconds to less than 1 second. The memory usage? It plummets because you're only holding a tiny chunk at a time, not the whole 15 megs. And because you're not trying to process a giant string all at once, the UI never freezes. It's just a massive win on every single front.
So here's the main takeaway. Streaming isn't some niche, expert-level trick. It's a fundamental technique for building modern, high-performance web apps. It gives you instant UI updates, keeps your app feeling light and fast, it stops those annoying browser freezes dead in their tracks, and honestly, it just delivers a way better experience for your users.
And that really just leaves us with one final question to think about for your own work. See, every time you write await response.txt or await response.json on data that could be large, you're essentially building a dam. You're holding back all that data until it's collected in one big pool. So the question you should ask yourself is, where in my code could I be opening the gates and just letting that data flow?